Hello students. In continuation with our series on assertion and reasoning, today we'll take electromagnetic induction. In our previous discussion, we have taken first discussion on how to tackle assertion and reasoning questions. What are the common mistakes made by the students? And what is the best way to attempt assertion and reasoning questions? After that, we have taken the different chapters. We have taken electrostatics. After that, we have taken current electricity, then the magnetic effect of current and magnetism. And today, we are going to discuss questions on electromagnetic induction. So before we start with the first question, let's first of all see what are the options given for this particular question. Options are assertion and reason both true, and reason is the correct explanation for assertion. Second option is assertion and reason both true, but reason is not correct explanation of assertion. Third option is assertion is true, reason is false, and the fourth one is assertion is false and reason is true. Whenever you are solving assertion reasoning questions, you first see what are the options given for that particular question. Because out of that options only you have to select the correct one, and since it may vary from question to question, so that is why you have to check what are the options given. Never take the options guaranteed that first one will be assertion and reason both true, reason is the correct explanation. Second is that assertion reason both true, reason is not the correct explanation. Third one is assertion is true, reason is false. Fourth one, normally there will be a change. Either assertion and reason both are false, or assertion is false, reason is true. Whatever options are there, just first of all go through the question and check what is given in that particular question there. So now after seeing these options, let's now take for this particular question, what is the assertion and reason statement? The statement is that two identical loops of copper and Aluminium are rotated with same speed in the same magnetic field. The induced e.m.f will be same. And the reason is that resistance of the two loops is equal. Now, first let's take, if suppose you have a coil, whether it is made of copper or aluminium, and if you are assuming that it is being rotated in a magnetic field, definitely magnetic flux linked with that one will change and there will be e.m.f induced, because magnetic flux linked with the coil, if I consider, it is your NB dot A, that we can write it as your NBA cos theta, and theta we can express in terms of the angular speed there as omega t, so it is your NBA, then it is your cos omega t. Now if I take e.m.f induced, this is your minus d phi by dt, so in that case it is your minus NBA, and then it is your differential of your cos omega t, so this is your minus sine omega t, and then it is your minus, and then it is your omega there. So basically it will be your NBA omega, and then it is your sine omega t. So here you can see that it is given that we have the identical loops of copper and aluminium. So in that case we can assume that N and A are same for them. They are rotated with the same speed in the same magnetic field, so omega and B will also be same. So the e.m.f induced will be same. So all the terms are same for the two. So in that case this is true. And now let's take the reason. Resistance of the two loops is equal. Now this is not correct, because even if you have the identical copper and aluminium coils there, but since they have the different specific resistance, in that case their resistances will be different there. So in that case this is false. So assertion is true, reason is false, that means the third option is the correct one. Let's take the second one. Magnetic flux of a magnetic field B passing through an area A is given by the relation phi is equals to B dot A. And the reason is given that the quantity obtained by product of the two vectors is always a scalar. Now, magnetic flux is basically the number of magnetic lines of forces passing through an area or given area normally. So it is given as your B dot A. So this is the correct one. So this is true. Let's take the reason. Quantity obtained by the product of the two vectors is always a scalar. Remember, assertion and reason, whatever is given there, read them carefully and see in the particular context of the assertion and reason how it is mentioned. So here it may be, since it is mentioned that magnetic flux is given as your B dot A, that is the scalar product of B and A. So don't take it there that it is referring to that particular case only, because it is said that quantity obtained by the product of the two vector is always a scalar. This is not true, because if the two vectors are there, their product may be a scalar quantity or it may be a vector quantity. So there they are just writing that one in a generalized statement, although in the first part it has been mentioned there or it has been given as a scalar product. So this is false. So now we have the assertion true, reason false. So in that case, again, it is the third option, which is the correct one. Let's take the next question. When the magnetic flux changes around a metallic conductor, the eddy current is produced. Now, this is true. You have a magnetic flux, and if the magnetic flux is changing around a metallic conductor, the eddy current will be produced, because whenever you have a metallic conductor subjected to a changing magnetic flux or magnetic field, in that case there will be eddy current developed. So this is true. And the reason is given that the electric potential determines the flow of the charge. Electric potential determines the flow of the charge. This is the correct statement, because the flow of the charge will always be from a point of high potential to a point of low potential. So this is also true. But now let's see if the assertion and reason both are true, whether it is the first option is correct or the second one. So for that, we just take assertion and reason and we use a word because between them, and we just check whether it makes a sense or not. So let's just see that when the magnetic flux changes around a metallic conductor, the eddy current is produced because electric potential determines the flow of the charge. This is not the correct statement to explain the assertion part. So here, this is the second one, which is the correct option, because the reason is not explaining correctly this assertion statement. Let's take the next question. Assertion is, if a straight wire is moved in a magnetic field, no EMF will be induced across its two ends as the circuit is not closed. And the reason is, since the circuit is not closed, induced current will be zero. If you have a conductor, it is moving in a magnetic field. In that case, there will be potential difference developed across its ends, because the free charge is there in that particular conductor. Due to the motion of the conductor in the magnetic field, they will move because they will experience force. So they will move from one point to other, making a potential difference to develop across its end, which is basically the cause of the EMF induced across the ends of that. So, and you know that that particular EMF, we take it as your BLV sine theta. So in that case, if it is saying that no EMF will be induced, this is false. Let's take now the reason part. Since the circuit is not closed, the induced current will be zero. This is also true. You have a conductor. Suppose you have a conductor and there is a potential difference developed. Suppose this end is plus, this is minus. But as this is not a closed circuit, definitely induced current will not flow through it. So that means this is false, but reason is true. That means the fourth option is the correct one. Let's take next question. Mutual inductance becomes maximum when coils are wound on each other. And reason is mutual inductance is independent of orientation of coils. Now, if you consider a coil, suppose this is one particular coil and the second one is wound over it. So obviously the flux leakage chances will be very less. Maximum flux which is linked with one is associated with the other one. So in that case, the mutual inductance will be maximum. This is true. Because whatever is the flux linked with one coil, if it is going to the second one and there is minimum amount of flux leakage, in that case there will be the maximum value of the mutual inductance, because that one is going to produce the maximum change in the magnetic flux linked with the other one. Second one is that mutual inductance is independent of orientation of the coil. If the two coils are there, in that case the mutual inductance depends upon the position of the coils and also on the orientation of the coils. So in this particular case, this statement is false. So here assertion is true, but reason is false. So that means the third one is correct option. Next, self-inductance may be called the inertia of electricity. And the reason is given: due to self-inductance, opposing induced e.m.f is generated in a coil as a result of the change in current or magnetic flux linked with it or linked with the coil. Now in this one, self-inductance may be called as the inertia of electricity. This is correct, because inertia was basically an state, or the, you can say, the ability of a particular material or the object to oppose any change. So for this also, self-inductance, if you consider, it will oppose any change, whatever is the change of the current associated with that, due to which its magnetic flux is changing. So there will be e.m.f induced. So it will oppose that particular change. So this is true. And reason, let's take due to the self-inductance, opposing induced e.m.f is generated in a coil as a result of change in current or magnetic flux linked with the coil. So this is also true, because there will be e.m.f induced in a coil whenever there is a change of the current associated with it, or whenever there is a change of the magnetic flux linked with it. So this is also true. And let's just now see whether assertion and reason which is given, whether the reason is the correct explanation for assertion or not. So for that, let's see that the self-inductance may be called the inertia of electricity, because due to self-inductance, opposing induced e.m.f is generated in a coil as a result of change of the current or magnetic flux linked with the coil. This is explaining it, why it may be called as the inertia of electricity. So that means it is the correct explanation for the assertion. So the first one is the correct option. Let's now take the next one. Inductance coils are made of copper. This is a correct statement. This is true, because inductance coil we are using in the different appliances there, or in the cases, and these are the one which offer minimum ohmic resistance. So we take for the copper, this is true. Induced current is more in wires having less resistance. Now this part, if you consider, induced current is more in wires having less resistance, because in this case, if you consider, current is more there having wire less resistance. This is true, because in this particular case, if you consider, since resistance is less, there will be particular potential difference. So if the potential difference is fixed there, and in suppose the current is flowing, definitely in that particular part there will be a high amount of current flowing if the resistance is less, because of V, if you consider constant, then I will be inversely proportional to R. So that means this is also true. And now let's see that how the two statements are related. Because both are true, so now inductance coils are made of copper because induced current is more in wires having less resistance. So this is explaining it correctly because the copper has less resistance there and the induced current will be more there in this particular case. So obviously this is explaining it correctly. So the first one should be the correct option. Next question. Assertion. When coil in galvanometer with metallic core oscillates, then electromagnetic damping occurs. And the reason is given: eddy current generated in the coil opposes the motion and brings the coil to rest quickly. Now, this particular question, if you consider, it is given that when coil of the galvanometer with metallic core oscillates, definitely if you have a conductor subjected to a changing magnetic flux, there will be EMF developed. So electromagnetic damping will be there because there will be energy loss there. It will try to oppose its motion. So this is true. And the second part, eddy current generated in the coil opposes the motion and brings the coil to rest quickly. This is also true because the eddy current is generated just because of the motion of that coil in that magnetic field or the conductor in that magnetic field. So since eddy current is developed, it is opposing the cause which has produced it. And what was the cause? It was the motion of the conductor there. So it will oppose it. So now both are true. So let's just see whether the first one or the second one the correct option. When coil in galvanometer with metallic core oscillates, then electromagnetic damping occurs because eddy current generated in the core opposes the motion and brings the coil to rest quickly. So this is explaining it properly there. So the first one is the correct option. Let's take the next question. Assertion is, in the phenomena of mutual inductance, self-induction of each of the coil persists. And the reason is self-inductance arises when the strength of the current in same coil changes. In mutual inductance, the current is changing in both the individual coils. Now let's see the first part there. In the phenomena of mutual inductance, self-inductance of each of the coil persists. This is true because magnetic flux linked with one will make a change of magnetic flux associated with the second coil, and there will be induced current developed. And if the current linked with the second one is changing there, it will also associate a magnetic flux to link with the first one also. So this is correct. So this is true. And self-inductance arises when the strength of the current in same coil changes. In mutual inductance, current is changing in both the individual coils. So this part, if you consider the second one, in self-inductance, in the same coil, it is the current is changing. So there will be EMF developed and the current will be there, induced current will be there. In mutual inductance, it is changing in both. So this is also true. And now let's just see the two statements together. In the phenomena of mutual inductance, self-inductance of each of the coil persists because self-inductance arises when strength of current in same coil changes. In mutual inductance, the current is changing in both the individual coils. Now this is not explaining the first part. Although it is saying that what will happen in self-inductance, what will happen in mutual inductance, but it is not explaining why there is self-inductance in each of the coil there. So obviously in this case, second one will be the correct option. Assertion and reason both are true, but reason is not the correct explanation for assertion. Let's take the next one. Mutual inductance of two coils depends upon the distance between the two coils and their orientation. And the reason is given, it does not depend on the magnetic material field between the coils. Now assertion part, if you take, mutual inductance of the two coils depends on the distance between the coils and their orientation. This is true because the mutual inductance will depend upon the orientation and also the separation of the coils there. And the reason is there that it does not depend upon the magnetic material field between the coil. This is false, because if you are putting a magnetic material there in the gap between the two, in that case magnetic flux link with that one will change, and if it is changing, in that case definitely the mutual inductance will also change. So this is false. So now here assertion is true, reason is false, so the third one is the correct option. This was the discussion on some of the questions on electromagnetic induction. We'll continue with this one with more questions in next discussion.